R5, rational expressions. So I don't think we'll get through all this today because it's a really long section, so I'm probably going to do about half the examples today. Then wrap them up on Tuesday because, quite frankly, if I do them all today, you're probably going to have questions on Tuesday about it because when you go to do the problems, because I'm not giving you any homework over the weekend, so long weekend. I want the time off. I'm sure you do too. So we'll just do a little bit, and I'll probably give you problems off of where we're at, but they won't be due until like next Wednesday when we finish the section. So, but all that to say, if you decide you want to do them over the weekend, I won't stop you. But I don't want you to have to do them this weekend. So the first one say to perform the indicated operation and write the answer in the lowest term. So basically just simplify it as much as possible. So if we have something like number 8, we've got 4 over x minus y minus 9 over x minus y. In this case, I have a common denominator, so I can combine the top of them. So I can do 4 minus 9, which is going to give me a negative 5 over x minus y, and that's as simplified as I can get that one. But obviously, they're not always going to give us a common denominator. So if they give us something like number 10, where it's 7 over x squared minus 8 over y, I need to get a common denominator for that. And so I'm sure that you're familiar with getting a common denominator with numbers on the bottom. Maybe not as much with variables, it just depends. And so what we do is I look and I've got an x squared on this one, I've got a y on this one. So whatever the denominator is on the one, I multiply the other one by that and vice versa. So this one over here is going to get multiplied by y over y. This one by x squared over x squared. And so then that gives me 7y minus 8x squared on top, because I'm going to have a common denominator now so I can combine them, over x squared times y, which is my new common denominator. The next problem say to find the domain of each rational expression. And so basically we've got 2x minus 4 over x plus 7, and I have to tell what numbers are in the domain. My domain are my x values that the function takes on. And so when I'm trying to find domain, I'm trying to see is there anything that's going to cause a problem. And so with this one, what I'm looking for is, with a rational expression, is anything that makes the denominator 0, which ultimately we'll find out. I don't think it's in this section. I think it's in a later section, but that those are vertical asymptotes as well. But to find the domain, I'm going to set the denominator equal to 0. So x plus 7 equals 0, and solve for x. So x equals negative 7. If I plug negative 7 in, that gives me a denominator of 0, which is going to be a problem. And so when I write my domain, at least the way I write it, there's a couple different ways you can do it, but the domain of this problem goes from negative infinity to negative 7, and it's going to be a parentheses because I'm not including that part of the domain, union negative 7 to infinity. And so all that's telling me is any number works for x except for negative 7. If we have one like 14 where it's 9x plus 12 over 2x plus 3 times x minus 5, I do the same thing, but now I have two different pieces that I need to set equal to 0. So this one's already been factored on the bottom, and that's what the two parentheses are. Sometimes they may not have already factored it, and you may have to factor first and then set each piece equal to 0. So I'm going to have 2x plus 3 equals 0, and x minus 5 equals 0. So obviously this one over here, nice and easy, x equals 5, which means that that's not in the domain. Over here, 2x equals negative 3, so x equals negative 3 halves. So I now have two numbers that cannot be part of my domain. So when I write the domain for this one, it's going to be a little longer. I'm going to have from negative infinity to negative 3 halves with a parentheses because it's not including that, union negative 3 halves to 5. Again, not including, that's why they're parentheses. Union 5 to infinity. And so that tells me that I can use any number except for negative 3 halves and 5, and that stuff will be part of my domain other than those two numbers. Any questions on those so far? Okay. Let's see, 16, 3 over x squared minus 5x minus 6. So we're still doing the same thing. But this one, notice they have not already factored it for us, and so we need to do that. So I'm going to take the bottom and attempt to factor it. Do y'all know what the factors are of negative 6 that add up to give me negative 5?
Negative 6 and 1.
Yep, negative 6 and 1, so that's going to be x minus 6 and x plus 1 are my two factors. And then I can set both of those pieces equal to 0. So x minus 6 equals 0, x plus 1 equals 0, and get that x is 6, x is negative 1. And then the domain for this would be from negative infinity to negative 1, union negative 1 to 6, union 6 to infinity. I had to smush that in there. Well, I wasn't going to do another one of these, but this next one's interesting, so I'm going to do one more. Number 18, I've got x squared minus 25 over x minus 5. So this one's a little bit interesting because if you're not careful, you will just set the denominator equal to 0 and solve. But the top is something that I could possibly factor. It's a special type. It's a difference of squares. So I'm going to factor that first, and I'll show you why. So when I factor that, I get x plus 5 times x minus 5 from that difference of squares over x minus 5. And either of you see what happens now? What is it?
You cancel out the x minus 5 on the top and bottom.
Yep, I can cancel those two since multiplication is happening, which means that I'm just left with x plus 5 on top. Stuff on top does not affect the domain for these, and so my domain it's this fancy R, so it's like 2 lines and an R, which means all real numbers. That means that there are no problem numbers for this problem. So if you can factor the top, always look to see if you can first, because stuff like this happens a lot, which is really, really nice, especially if you end up going on into like calculus. Even though you may not be finding like the domain of something, there's a lot of stuff we do where we want to be able to cancel stuff top and bottom. So if you plan on continuing in math past this, can be really useful to be used to looking for that as well. Write each rational expression in lowest terms. So I've got number 24 on top, -8 times 4 minus y over y plus 2 times y minus 4. So what do we notice about this problem to start with? Or is there anything that can cancel from the beginning? No. But what I could possibly do is, doesn't this kind of look like this? The terms are just flipped, these two. So if I take out a negative, so if I like factor out a negative from the top, then what I would have is negative times -8. So this negative is going with this other parentheses. And then I can flip these in here to be y minus 4, because I took a negative out, so this became positive, this became negative. We tracking on that? So then on the bottom, I've got y plus 2 and y minus 4. Now, I just wrote this double negative like this so that you could see where I took it out, but obviously we know that a negative times negative is going to be positive, so that's gone. I also now have a y minus 4 top and bottom, so I can cancel that, and ultimately then I would be left with 8 over y plus 2. So our goal with these is just to simplify them down as much as possible with what I have. Let's see, 26. I've got 20r plus 10 over 30r plus 15. Any ideas what I can do to this one?
You could take 5 from the top and the bottom.
So, yes, I could, but I can also just work on the top and then just the bottom and then see what happens. So ignore the bottom for right now. Is there something I can take out of the top?
10.
Yep, I can take a 10 out of the top, which is going to give me 10 times 2r plus 1. What about the bottom?
50.
You can take out a 15, which is 2r plus 1. And so now what can happen?
You can cancel it out.
Yep, I can cancel the 2r plus 1, and I have 10 over 15. Can that reduce any farther? What am I taking out of that?
2/3.
Yep, I'm taking out 5s from each, which will give me 2/3. Let's see, 32. Y cubed minus 27 over y minus 3. What do we notice about this one?
Difference of cubes on the top.
Yes, the difference of cubes. And so, what does that factor into from my difference of cubes? Or if we need to think about it, what cubed is 27?
3.
Yeah, so I'm going to rewrite this as 3 cubed to help us. This one's our SOAP formula.
Same opposite, always positive.
Yep, same sign, opposite sign, always positive. So in here I've got y same sign, minus 3 times first term squared, so y squared, opposite sign, so positive. It's the first term times the second term, so that's going to be 3y. And then always positive, the last term squared, so 3 squared is 9. Over y minus 3. And then now these so nicely cancel out for me so that I'm just left with y squared plus 3y plus 9. Any questions on the canceling, reducing stuff? So the biggest thing is when you're doing these problems for that particular section, at least one thing should end up canceling. So if you're not getting anything canceling, then try factoring, try taking something out. I've tried to do kind of a variety so you see some of the different things, but I'm sure there's some in here that I didn't touch on how, like what it's a little different or whatever, but it's some type of factoring something out. So just be aware of that. The next set of problems, and it's going to be the last, this is going to be like our stopping point for today. It's about halfway through the problems. It says to multiply or divide as indicated. And so to start with, we've got 34. And so I've got 8r cubed divided by 6r. That's a fraction. Divided by, so I have a little divided symbol here, 5r squared over 9r cubed. Now, does anybody know or have a saying for when you divide by fractions? What's it's the same as doing, or?
Keep change flip.
Yep, keep, change, flip. So I keep the first fraction. So I have 8r cubed over 6r times, we change the signs, we're going to multiply, and I flip the other fraction upside down, so I'm going to have 9r cubed over 5r squared. Now, obviously, from the beginning, I could have reduced these fractions down and made my life a lot easier, so I'm probably going to do that now before I start multiplying things together because, quite frankly, I would rather make my life easier. So, I'll combine the exponents on the r's, but the numbers I'm going to reduce. So, 6 and 8 reduce to 4/3. And then I can reduce this 3 and this 9 and make that 9 a 3. This number's completely gone over here. So now on top, I've got 12, add the exponent, so r to the 6th over 5, add the exponents, r cubed. And then I just need to reduce those r's, and so that's going to be 12 over 5 r cubed to finish it out. We're okay on rules of exponents, right, and all that. Okay. All right, 2 more for today, and then we'll be done. 40. I've got 6r minus 18 over 9r squared plus 6r minus 24 divided by 4r minus 12 over 12r minus 16. So I'm going to do something a little different in this one than I did on the last one, just to make my life easier. Is there anything I can take out of the bottom of this one? And you'll see why I'm doing the bottom first in just a second. No, because it has to come out of all 3 pieces.
Just 3, right?
Yeah, just 3 for that one. So I can take out a 3. So I'm going to rewrite it down here. So 3 times 3r squared plus 2r minus 8. Now, on the top, what can I really take out? Like what? Yeah, so I can take out a 6. However, I was only able to take a 3 out of the bottom, and I want something to completely cancel so that I'm not having to distribute back. So I'm only going to take out a 3 in this case. Okay, it's not wrong if you take out a 6, but you're just going to end up distributing it back, and it's probably going to be more annoying. So if I take out a 3, then I'm left with 2r minus 6. And so from this one, these 3's will go away, and this is what I'm left with for that one. Now, divided by, what can I take out of the top of this one? 4, which leaves me with r minus 3. What about the bottom?
4. 6. No,
4. Which leaves me with 3r minus 4. And so again, on this one, I've got 2 numbers that can cancel. So now, aside from possibly needing to factor this piece out eventually, I have factored everything to cancel as much as possible for the given, original situation. So now, some dividing fractions, I'm going to cube, change, flip. I've got 2r minus 6 over 3r squared plus 2r minus 8 times, flipping this one, 3r minus 4, excuse me, over r minus 3. So now, I know this side is factored as far as possible. This side, when we did the top originally, we were like, yeah, that's not factored all the way. So if I wanted to finish factoring the top, what is that going to become? Or what can I take out?
R minus 3.
Yep, so I'm going to have 2 times r minus 3. So I'm just going to cross through that since I have rewritten it that way. What about the bottom? Can I factor this piece into what? So I'll do it off to the side over here. 3r squared plus 2r minus 8. So I need factors of arch method negative 24. That one added together give me a positive 2.
6 and negative 4.
Yep, 6 and negative 4. So that'll add up and give me a positive 2. So I'm going to have 3r squared plus 6r minus 4r minus 8. I'm going to get rid of this over here now so I can have room. Factor by grouping. Take out a 3r. I'm left with r plus 2. Over here, factor out a negative 4. Left with r plus 2. And so I have 3r minus 4 times r plus 2. So I'm going to just cross this out so I don't have to rewrite the whole thing and rewrite this as 3r minus 4 times r plus 2. So now this fraction's rewritten as 2 times r minus 3 over 3r minus 4 times r plus 2. So now what do we see can happen?
We can cancel out the 3r minus 4.
Yep, 3r minus 4 cancels. Can anything else cancel?
R minus 3.
Yep, the r minus 3's can cancel. And so I have on top, all that I'm left with is a 2. On the bottom is r plus 2. And so that would be all of that. All right, one more and we will wrap it up for today. And that'll be about half the section. So 42, I'm getting a little crazier. I've got on top x squared plus 2x minus 15 over x squared plus 11x plus 30 times, so notice I'm not dividing on this one, x squared plus 2x minus 24 over x squared minus 8x plus 15. So I need to factor each of these pieces, so 4 sets of factoring here in this problem. But the nice thing is all the x squared just have 1 in front, so it's a lot easier to factor those. So what does this top left one factor into? So factors of negative 15 add up to 2.
5 and negative 3.
Yep, 5 and negative 3, because those two added together give me a positive 2. So x plus 5, x minus 3. What about the bottom of this one? Factors of 30 that add up to 11. 6 and 5, so x plus 5, x plus 6 times top one over here, factors of negative 24 that give me a positive 2. 6 and negative 4, x plus 6, x minus 4, and bottom one, factors of 15 that give me negative 8. Yep, negative 5, negative 3. So x minus 5, x minus 3. And now I'm just going to do a mass cancellation of everything. Since it was multiplication, I don't have to flip anything around. So I see an x plus 5 top and bottom. I've got an x minus 3 top and bottom. I've got an x plus 6 top and bottom. And that leaves me with x minus 4 over x minus 5. And that's all I've got. Any questions about any of the stuff we did today? No, it's not necessarily like awful, but it can be kind of time consuming just because of all the factoring stuff out and canceling and whatever. So your problems as of today, but like I said, if you want to do them now, that's fine. If you need to study because everyone's trying to get their quizzes and tests in before the long weekend, I don't care if you do that either. We'll finish this section on Tuesday since obviously we won't be here on Monday. And yeah, anyways, so 9, 15, 19, 27, 35, and 41. And you will need R6 notes for Wednesday. So, and that section may take us 2 days. Also, these last couple of sections are kind of just like longer, like more time-consuming sections. They're not like super hard, but so just be aware of that as well.